Right.
You're going to want to then do some additional follow-up to make certain that that's not going to be a problem. And if it is going to be a problem, you're not going to want to fill the dam up.
Walter, if this happens, if it starts to get created, how soon would we know about it? How soon would scientists be able to say, oh, no, we've done something wrong?
Well,
right away, or would it take a while before they knew it?
It would take a long while before we knew it. You would not see these things. They would disappear, so to speak. You would not detect them with your detectors because they would barely interact. Some people have referred to them as being neutrino-like. That they would pass through matter very easily, and it would take many days of passing through matter before it would interact with an atom, and then grow a little bit larger. Then the next interaction would be a little bit shorter period of time, and then the next interaction a little bit shorter period of time as it slowly grew larger. So you would never see it in your detector, in your particle detectors. And so the only way you would detect it later on would be its effects on the planet.
And it would be too big by then.
And by that, you wouldn't be able to do anything, even if it were still small. You wouldn't even feel it until it's at the very end stages of devouring the Earth. You would maybe only minutes before the Earth were devoured start feeling earthquakes.
I mean, would we get a sign, though, Walter, that maybe, let's say, a satellite got too close to the black hole and got sucked in? And
no, it would pass right through the satellite, and the satellite wouldn't be affected.
Would not be affected.
It would not be affected until eventually, when it's growing larger and larger, and it's entirely inside of the Earth. At that point, it might be possible we would be able to somehow detect it deep down in the Earth that there was matter, rumblings within the Earth, so to speak. But by the time you would detect it, it would be at the very tail end of its consuming of the planet. It would start rapidly accelerating, and it's eating up the Earth. And you'd have minutes of notice, and that would be about it.
I'll give you a quote. James Gillis, a CERN spokesperson, says, "This talk is all rubbish," in response, for example, to the New Scientist magazine that says the LHC will start up this year. And he says it will produce all sorts of exciting new physics and knowledge about the universe. Now, what's your take on his verbiage, "this is all rubbish"?
Well, Gillis is not a physicist. He's a spokesperson and a promoter paid by CERN to present an optimistic view. And certainly it will produce new physics. There's a good 50% chance that if lawsuits don't work and they have their way and they fire it up, that nothing bad happens. And so, he's one of the ones who's thinking, hey, look, we were right, nothing bad happened. But at the same time, you wouldn't know whether something bad had happened or not. So it's easy to say nothing bad will happen, but when you look at the physics of what's going on, there is that potential there, and there is no clear proof that these potentials for something bad to happen can occur.
Why did they make the particle accelerator? What do they want to learn?
Well, there's always, the question of what happens when you bang two atoms together faster than you ever have before. You're going to make something different, possibly. And so that's the ultimate, we've never done this before. It's a higher energy. We've never done it at this energy before. So let's see what happens. And that's the basic goal. Now, there are certainly a lot of theories that people want to test. There are theories as to whether or not it might make a strangelet. That's one of the theories that's out there people want to test. There are theories as to whether, and they have the belief that strangelets would be okay to make. But we don't know that. There are theories that it might make a magnetic monopole. There are experiments that are planned for testing to see whether or not it would make a magnetic monopole. There are theories to see whether or not what's called the Higgs field is actually something that's there that creates mass, and whether or not that theory is correct. So there are all kinds of experiments people want to do to test whether their theories are right, and none of them have really thought about what the consequences of some of the other theories that they haven't been thinking about. What if they're right? Jeez. And so that's what I've been concerned about. Some of these other theories are downright scary, and I haven't seen any proof that they can't occur.
Well, now, what are other scientists saying about this, Walter? Anybody in your camp?
Yeah, quite a few. You know, the lawsuit that was filed, you know, and when I spoke with you last August, we hadn't gotten around of filing the lawsuit and so forth.
Right, you hinted about that.
Right. We filed it a little over a month ago. There are 7 sworn affidavits from scientists and engineers that were filed in support of it as well. And we have quite a number of other physicists we've spoken with, and other scientists, who are encouraging us to go forward with this. They don't want to have their name out there and where they're going to be putting their head on a chopping block, so to speak. But they are saying that, yes, this is something that we need to look at, and we need to examine this thoroughly before we can start this machine up. And they're I end up speaking with a lot of scientists either by blogging or emailing with them, and I do a lot of explaining. At first, they don't know where I'm coming from. They haven't heard some of these theories before. They've been sort of led to believe that there's no problem by the PR that comes out of CERN. And as I explain to them what the problems are and the difficulties are, they recognize that, yeah, okay, there is a problem. And some of them just didn't sort of shy away. They don't want to get involved. And others do end up indicating that they are very concerned about it as well.
I'd feel a lot better about this thing if you weren't a physicist, but you are. That means you know more than I do.
George, everybody out there in the world has a degree of knowledge of things, and nobody shares the same exact common knowledge. There are a lot of things you know that I don't know, and vice versa. But yes, I do know quite a bit about physics. I've worked in the field for many years, and worked with some very competent people, and acquired a great deal of knowledge about how physics works. And that's what's impressing a lot of the people, even at CERN, is the one fellow that said it'd be easy enough to dismiss this by waving our arms, except these people are physicists.
Yeah, that's right. Walter, stay with us. We're going to open up the phone lines because there's a lot of people who want to talk with you. They've got questions, too. So we'll give you the numbers in just a moment. Our special guest tonight, Dr. Walter Wagner. We're talking about CERN, Switzerland, the particle accelerator, and the possibility of black holes. I'm George Norrie. This is Coast to Coast AM. Well, 1-888-727-5505. That's 1-888-727-5505 is the toll-free number to order the After Dark newsletter. And also, if you renew, you'll get the CD called J.C. Webster Rants. It's the last week that this CD will be available to you and is bound to become a collector's item, so take advantage of it. And if you don't want to make the phone call, you can just order online very safe and securely at coasttocoastam.com. And welcome back to Coast to Coast. I'm George Norrie with Dr. Walter Wagner. This is not April 1st. We're talking about the particle accelerator at CERN, where Walter and a number of other scientists believe that we could create black holes around the planet, and then something even more disastrous later on. Walter, didn't the Soviet Union at the time launch a dozen or so reactors into space? And whatever happened to those?
Yeah, George, did I email you about that way back when? I must have, because not too many people know about that.
Yes, you did. I do my homework, Walter.
Yes, the Soviet Union way back when, 30 years ago or more, used nuclear reactors to power their satellites. The U.S. program used radioisotope generators. They'd use the heat from the decay of the radioactive materials. The Russians used actual nuclear reactors. This was a barely subcritical mass of either uranium-235 or plutonium-239, and they would surround it with what would look like a Venetian blind of graphite. When the blind was open, any of the neutrons being produced inside of